Okay, welcome to our first video for Unit 2 in astronomy. Our first learning target is galaxy formation. So we're going to try to describe how the Milky Way galaxy, or really any galaxy, forms, and how our solar system formed inside of the Milky Way galaxy. So there's 4 learning targets for this unit. The first is galaxy formation. And after we talk about galaxy formation, we'll talk about sun activity, star formation, and where everything came from in the Big Bang. The questions we're going to try to answer today in this video are: can you explain the size difference between the solar system and the Milky Way in the universe? Can you explain where and how the Earth moves in our solar system in the Milky Way? And then, can you roughly explain how the Milky Way and our solar system form? So we're going to do a very brief explanation and not a very detailed one. So to understand our place in the universe, we're going to start with the Earth. And if we were to back away from the Earth very quickly, even faster than the speed of light, we would the first major structure that we would see of organization is our solar system. So we've got the Earth and our 8 planets plus a bunch of other stuff. But the solar system is not the only structure to our universe. If we were to back out a little bit more, our solar system is one of a bunch of systems in our interstellar neighborhoods. These are all the closest stars to us. Just for perspective, our nearest neighbor, Alpha Centauri, is 4 light years away, meaning if you traveled at 186,000 miles per second, it would take you about 4 years to get there. So while this picture makes it look like they're relatively close, these distances are huge, and under our current ways that we travel through space, we would never be able to get there in a lifetime. But if we back up a little bit more, we can see our collection of stars is right here. We can't even make out the individual stars. We're just one of a few billion stars going around the Milky Way galaxy. But our galaxy is one of a couple galaxies in our galactic group. We've got 2 major galaxies, us and Andromeda, and then there's a bunch of little smaller either dwarf galaxies or clouds of stars. So this is our local galactic group. But if we were to back out a little bit more, just one of these dots is our local galactic group, and then each dot basically represents a group of galaxies. And so this is in our supercluster. Excuse me. And if we back out a little bit more, our local superclusters, so each of these dots represents the supercluster. And so there are billions upon billions of galaxies just in this picture. And if we back up even a little bit farther, one of these dots represents the supercluster, our local supercluster. So there are billions upon billions of galaxies in our universe, and our observable universe is by definition everything that we can see. So this would be the edge of our observable universe. So to kind of put that all in one picture, here's Earth, which is one part of the solar system, which is one part of the Milky Way, and the Milky Way is one of billions of galaxies in the entire observable universe. So what are galaxies? They're just large groups of mostly stars, but there's a lot of gas and dust, and the reason why it's all in the same spot is because it's being held together by gravity. And gravity is a force that we're going to be talking about a lot in this unit. Gravity is responsible for pulling in galaxies, pulling in solar systems, making stars. Gravity is super important when we talk about galaxies. So there's 3 types of galaxies that we briefly talked about. We have elliptical, which are egg-shaped; irregular, which by definition can be any shape; and then spiral galaxies, which are usually in a nice flat disk. There's different categories of how flat it is, or if it has any special shapes to it, but ultimately we have 3 main categories of galaxies, and we are a spiral galaxy. So if we go back to the questions, our second question that we're going to try to answer now is, can you explain where and how the Earth moves in the solar system and the Milky Way? So here's a picture of our solar system. Earth is the third planet from the Sun. This is not to scale, even remotely. We know from our scale model that we did, if the Sun is about a meter, the Earth is pretty far away. It was something like 30 some meters away, and it'd be about the size of a pea. Jupiter, which was very far away, would only be about the size of a softball. So our solar system is mostly empty space, and the planets, which are the biggest things besides the Sun, are actually pretty tiny. So we are the third planet from the Sun. It takes us 365 rotations to make one lap around the Sun. Our location in our galaxy is a little harder to figure out, but we know that we're in the Milky Way galaxy because when we look up the night sky, we see a very bright band of stars running down the middle of the sky. We don't always see it because most of us live in cities and light pollution kind of blocks out the starlight. But if you ever get a chance to go out in the country and on a clear night look up at the stars, the Milky Way is very prominent and obvious. So we know we live in a spiral galaxy because of this disk of stars that we're looking out through. So the reason why we see a flat band is because the Sun or our solar system is here, and we are looking, through the flat arms of our solar system. But if we were to look, straight up or down, which would be, coming out of the screen or going into the screen, it's darker because there's less concentration of stars. So we've been able to determine through parallax and some other stuff that we're about halfway to 2/3 of the way out from the galactic center. So this is the center of our galaxy, and so we're a little more than half the way out. So this is a pretty inexact measurement of where we're at, and that's because it's hard to tell exactly where our galaxy stops. If you keep going, there's still stars that are going around, so it's kind of hard to say here's the border. So a better measurement would be, exactly, how many, light years or something like that. But for our ninth grade class, halfway to 2/3 of the way out is good enough. And here is the path. So just like the Earth goes around the Sun, our Sun goes around the Milky Way galaxy. And we'll come back to this later, but basically the brightest stars are in the center, and that's where most of the older stars are, and younger stars are in the arms of the Milky Way galaxy, where we still have nebulas that are being pulled in by gravity. Okay, on to the last question, which is, can you roughly explain how the Milky Way in our solar system formed? So we're going to start with a nebula. A nebula is a giant cloud of gas and dust. It's mostly hydrogen gas, and it starts to get pulled in by gravity. So these clouds, smaller clouds, get pulled in and start to get form a bigger cloud. And for our spiral galaxies, they start to rotate. And just like if you were to take pizza dough and throw it in the air and spin it, it tends to flatten out a little bit. Kind of the same idea. This rotation causes it to flatten, and this is how we got our Milky Way disk. So if we were to, so this is how our Milky Way galaxy formed. So again, giant cloud pulled in by gravity, starts to spin. But if we were to zoom in on just a tiny little part, there's a nebula, still nebula gas that's there that starts to spin. So we have still more nebula, more cloud of gas and dust that gets pulled in by gravity. We start to form a protostar, and once fusion begins, it becomes a main sequence star where it starts to fuse hydrogen into helium, and all the stuff that got left outside the star, the Sun, gravity pulls that together further to get the planets. So if I had to describe a 3-step process for how the planets formed, Nebula is pulled in by gravity. So here's our nebula pulled in by gravity. Most of the mass gets pulled into the sun or the star, and what's left becomes the planets. So there's only a tiny little bit of mass that's left for the planets. Okay, so one of the things that we also tried to do is understand the differences between our planets. So the inner planets are really small, dense, rocky, warm, and because they're smaller they have lower gravity, and they're warmer because they're closer to the sun. Our outer planets are bigger, less dense, gassy, cold, and because they're bigger they have more gravity, and they're colder because they're farther from the sun. So if we look at our solar system, so these are our 4 inner rocky planets. These are the 4 outer gassy planets. Pluto is a dwarf planet, so we're not going to talk about Pluto today. So these are warmer and more dense. These are larger, colder, and less dense. So the next question is, why are the inner planets smaller, rockier, and warmer, and why are these large, cold, gassy planets? So we'll so if we look at the way that they formed, the sun gives off a lot of energy. So because these planets are closer, they're warmer, and the gases that exist as a liquid on Jupiter, Saturn, Uranus, and Mars exist as gases on planet Earth, and the 3 other rocky planets. So the energy from the sun made them gases, and then solar wind from the sun blew them away, as the gravity for these planets are too small. So basically we're not big enough and we're too warm, would be the quick way of saying why we are not big giant gas planets like the 4 outer gas planets. And then just really quickly, where did the moon come from? We're pretty sure that moon was hit by a large asteroid or something about the size of Mars when we were still liquid and still forming, and that collision spewed out some material around planet Earth. Gravity pulled that in, and that eventually became the moon. And we're pretty sure this is how it happened, because when we went to the moon, we took samples of moon rock, and it is basically identical to Earth rock. So it couldn't have come from like an asteroid that we just caught in our gravity or something like that. It had to have been formed from Earth material when Earth formed. And then our atmosphere, just briefly, how do we get our atmosphere? So if we were to go back to when Earth first formed, and let's say we were in a time machine and we were to open it up, we would not survive very long because there would be no oxygen and there'd be a lot of nasty gases. So some of the gases that would be in our atmosphere would be hydrogen and helium. Hydrogen would not be good to breathe. Helium is inert, so that would be fine. But if you look at this picture here, we can see there's no oxygen. So the lightest elements got blown away by solar winds. So that's kind of step 1. We lost hydrogen and helium and some of the lighter things that were in our atmosphere. Then, as the Earth started to cool down, we had lots of volcanoes and lots of volcanic eruptions. And volcanoes spewed out a lot of nasty stuff like carbon dioxide, ammonia, sulfur dioxide, some really nasty stuff. But again, still no oxygen. So the last step to get our atmosphere the way it is today, the last major step anyway, is that organisms or plants turn carbon dioxide into oxygen. And that was kind of the last major event that changed our atmosphere to make it the way it is today. And that is it.